Okay, now we're going to continue, and we're on number 15, and we have h of t equal t cubed, and the point we're interested in is 2 comma 8. So we have the limit h approaches 0, f of x0 plus h minus f of x0 all over h. So in this problem we're doing t cubed, and so this would be x0, which is 2 plus h, and then we need to cube it, then minus our f of x0, which is 8, all over h. Okay, so this one we're expanding it just like we had expanded one from a different lesson on number 9. If you want to refer back to how we expanded 2 plus h on number 9, that was basically this one, expanding negative 2 plus h. Okay, so this one is a positive 2 plus h, and so the only difference is going to be some signs. We're going to have h cubed plus 6h squared plus 12h plus 8. And so this is the part from expanding the cube. Okay. Now you want your 8's to cancel and start dividing out your h's, so you get h squared plus 6h plus 12. So now you do your limit h approaches 0 of this, which gives you 12. So that's your slope. So that's part A. Part B, you do your y minus 8 equal 12 times x minus 2. So that'd be your answer in point slope form. Or you can distribute it and add 8, y equal 12x minus 16. So on this one, really they'd want it to be h of t. So h of t equal 12t minus 16. And on this it would have been h of t minus 8 equal 12 times t minus 2. So these are just with the t notation. Okay, so then to graph it, we do our graph as x cubed. You can't put t in the calculator. And then do menu, analyze, dy dx, and put position 2, and there you get 12. So then our answer was 12x minus 16. And so your tangent line is like that. Okay, that's number 15. Now number 17. On this one we have the limit h approaches 0. F of x equals square root of x, and our ordered pair is 4 comma 2. So we do our limit h approaches 0, f of x0 plus h minus f of x0 all over h. So then this turns into the function, which is square root. Instead of x we put 4, and then we put plus h. And then we're going to say minus, okay, this was our x0, f of x0, this is where we put 2 all over h. Okay, so the next step would be multiply by the conjugate. So when we do that, we multiply by square root of 4 plus h plus 2 over square root of 4 plus h plus 2. So again, the goal is to cancel your square roots, so you get 4 plus h. To cancel your middle terms, and you would because they're positive and negative, and then you get minus 4 all over h times the square root 4 plus h plus 2. Okay, here's where your 4 plus 4 cancel. So you have h over h square root 4 plus h plus 2. We still didn't distribute that because we want to cancel it. And so there we get 1 over square root of 4 plus h plus 2. And so this is where we do our limit h approaches 0 of this, and so this would be 1 over square root of 4 plus 0 plus 2. So this is basically 1 over 2 plus 2, and so you get 1/4 for your slope. Your limit is your slope. And so it's really related to our previous lesson. Okay, so the graph for this is the square root of x. We do our analyze and dy dx, and it's position 4, and we get 0.25, and so that's 1/4. So then y minus 2 equal 1/4 x minus 4. So that's our answer. Or distribute it and add, and we get 1/4 x plus 1. And so then we check our work. Parentheses 1/4, then x, then plus 1. So that's what our tangent line looks like. So it hits it in one spot. Tangent means it hits it in one spot. Okay, there's 17. Our next one is number 19. And on this one, the directions say find the slope at the point indicated. So on this one, we do the function 5x minus 3x squared, and the point is x equal 1. It doesn't tell you your y value. F of 1 is 5 times 1 minus 3 times 1 squared. So that's 5 minus 3, which is 2. So that means your ordered pair is 1, 2. And now you just work it just like we did previously. So you're doing your limit h approaches 0, f of x0 plus h minus f of x0 all over h. Your function starts with 5. Then you're going to put x, which is really 1 plus h. Then you're going to put your minus 3. And then you're going to put your 1 plus h squared. And then you're going to end up putting your minus 2. Because that's what f of x0 is. So now let's distribute and simplify. 5 plus 5h minus 3 times. Make sure right there you don't distribute the negative 3 first. You need to expand the 1 plus h squared. So you get 1 plus 2h plus 1. And then you still have your minus 2. Okay, keep on doing your algebra. 5 plus 5h minus 3 minus 6h minus 3 minus 2 all over h. Okay, so right there I just caught my mistake. When I was expanding this needs to be 1 plus 2h plus h squared. And so this would be minus 3h squared right there. Okay, so then 5 minus 3 is 2, and 2 minus 2 is 0. So that cancels out. Then you have 5h minus 6h minus 3h squared all over h. And so you get negative h minus 3h squared over h. So that gets you negative 1 minus 3h. So then the limit as h approaches 0 of this would just be negative 1. So that's your slope. There's no need to get the equation for this one. Again, you still could do your graph. So if you do 5x minus 3x squared and then do your menu, analyze dy dx and put in 1, then your answer is negative 1. So it's right there. Okay. Number 21. On this one, we have y equal 1 over x minus 1 with x equal 3. And so f of 3 would be 1 over 3 minus 1. So that's really just 1/2. So that means you have the ordered pair 3 comma 1/2. So again, we do our limit, h approaches 0, f of x0 plus h minus f of x0 all over h. So this would be 3 for our x value. Okay, so for our function we have 1 over x, so 1 over 3 plus h, and then we do minus 1. So 1 over, think of this as x, so 3 plus h, and then minus 1. So that's what you get, and then minus f of x0, which is simply 1/2, all of that over h. Okay, so what this simplifies down to is 1 over 2 plus h minus 1/2 all over h. Okay, so this is where you want to get a common denominator. And you can't just do the common denominator of 2 plus h. You have to do 2 plus h, but you also need a 2 because you have both of them. So we're basically going to multiply all of this by 2 times 2 plus h. Okay, so this would just be 2 minus parentheses. This would just be 2 plus h, and then all over h. Okay, so this just gets you 2 minus h over h. That cancels, and so you get negative 1. So slope is negative 1. I just did that too fast. Let's see. I did not multiply the bottom by 2 plus h times 2. Okay, so this is really h times 2 plus h. Okay, so what this needs to be, after you put your divide by 2 over 2 plus h, is we're going to make this 2h, so 2h and then 2 plus h. So what that gives us is really 4h plus 2h squared. Okay, so let me fix this real quick. My confusion was I went too fast, and this goes to the top and this goes to the bottom, but the h doesn't get multiplied by anything. So that's how I confused myself. Okay, so this is still 2 minus 2h, but then this part is just h. Forget the 4. Okay, so actually let me just cross out this and step through it. Okay, so this gives you 2 minus, then this part gives you 2 plus h. Okay, I'm confusing myself. Okay, let me just go with what I did before. Okay, so what I did before was I have my limit h approaches 0 of the function 1 over x minus 1, and instead of x minus 1 I put your 3 plus h minus 1, then your minus a half, all of that over h. So then you want to get a common denominator of 2 times 2 plus h on top. And so 2 times 2 plus h is right there. Okay, so when we do that, we get 2, then minus 1 times 2 plus h, and then over h. So right there, that's where I started confusing myself. So this is really 1 over 2 plus h minus 1/2 all over h, which ends up turning into 2 minus 1 times 2 plus h all over 2 times 2 plus h over h. Okay, so sorry about that earlier. Then we distribute and we get 2 minus h all over 4 plus 2h over h. These cancel, and so then you end up getting, this is over 1. You have negative h on top, and you have h times 4 plus 2h on bottom. And then this cancels. You do your limit, h approaches 0, and that would give you negative 1 over 4 plus 0, so you get negative 1/4 for your slope. Okay, so I finally got there. So what we could have done, like I've been doing earlier, is graph it, and then I have 1 over parentheses x minus 1, do our analyzed graph, then our dy dx, and its position is 3. And so you get negative 0.25, so that's negative 1/4. So that really should be the recommended way to do it, because it's a lot faster. Okay, on our next one, here we do the growth of yeast cells. And so we need to explain what P prime of 5 is, and then, our question is, what are the units? So you're doing the rate of change with the change in y over change in x of your number of cells when t is 5. So that's your time. So our ordered pair for that is 5, 125. How you know it is from the graph. So at 5, it goes up halfway between 100 and 150. So that's 125. So you can read through the problem. And so that's 5, 125 from the graph. And then it wants to know which is larger, P prime of 2 or P prime of 3. P prime of 2 is about 2, 25 for the ordered pair, and P prime of 3 is 45 approximately, because that's pretty close to where 50 is. Pretty close to 50. And so if this one's 25 and that's 45, then the slope when t equals 3 is greater. So that's your steeper slope. The next one is for p of t equal this function, and we want to know the instantaneous when t is 5, the instantaneous rate of change. So that just means put your 5 plus h in for t in every place, and then work it out like we did before. So the easiest way on this one, well, this is your work. The easiest way on this one is to just graph it like we did. And you have 6.1 x squared minus 9.28x plus 16.43. Okay, I graphed it. I'm going to do menu 4A to do a zoom fit. And then I'm going to do menu, analyze, dy dx, and my position is 5. And so I get 51.72. That's just so much simpler than working it all out. But you get 51.72, so 52 cells per hour is your answer. Then the next one, it's talking about horizontal tangent lines. At what points do the graphs have horizontal tangent lines? And so this one is x squared plus 4x minus 1. And so I want to graph that. X squared plus 4x minus 1. So there, and so first let's find our minimum. We do analyze, then the minimum between here and here. That's going to be interpreted as -2 for x and -5 for y. So your minimum is -2, -5. And so that means the tangent line would be y equal -5. So that's how you do it. Our next one is asking about an object dropped from a tower has this function, 100 minus 4.9 t squared. How fast is it falling after 2 seconds? So that you use t equal 2. Again, if you just do your position, you should get your answer. Now, when I did the work, I got negative 19.6, which means down, and so then your answer was 19.6 meters per second. So now let's graph it and prove it. So we go to our graph, we do 100 minus x squared, 100 minus 4.9x squared. Do your zoom fit, menu 4A. So there it is. Analyze it, do dy dx at 2, and you get negative 19.6, which is going down. And so then your velocity is 19.6. Okay, and then number 31. On 31, it's talking about a circle changing area. If you're using slider or a different type variable, we don't really do that on our calculator. What we do is just do this problem by hand. So we have area is pi r squared, which is the area of a circle, and we have a radius of 3, and we're using 3 plus h, so 3 plus a little bit, basically. And on this one, it doesn't look like you could probably type that in, because you'd get a decimal that you're not going to recognize. You should end up getting 6 pi after doing this work. So when you expand this, you get 9 plus 6h plus h squared minus 9 pi. Those cancel, and then your h's cancel, so you get 6 pi plus pi h, and so 6 pi is your answer. Let's see what we get on the calculator. If we say pi times x squared, and then do position 3, menu, analyze, dy dx at 3, that gives us this 18.85. So approximately 18.85. And so then if I go to the regular calculate screen and do 6 pi, let's see, as a decimal, 18.85. So this one, you'd probably have to guess and check with your numbers, or work it out by hand. Okay, our last one is about a vertical tangent line. And so, let's just cover this up. Okay, so a vertical tangent line, it's represented by this vertical line. We have a piecewise function that says -1 when x is smaller than 0, so that's over here. 0 when x is 0, so that'd be the origin, and 1 when x is greater. And so what it's asking is there a vertical line at the vertical tangent line at the origin? No, there's not, because it's not continuous. Okay, so now we're able to finish up that lesson, and now you can work on your Math Excel.